We often gaze up at the night sky, mesmerized by the twinkling stars and the vastness of space. It's a source of wonder, a canvas for our dreams, a cosmic ocean of possibilities. But have you ever stopped to consider the hidden dangers lurking within that breathtaking expanse? Out there, amidst the celestial ballet, lie forces of unimaginable power, cosmic events capable of ending life on Earth as we know it. In this series, we'll journey through the cosmos, exploring 5 such catastrophic events. From comet collisions to supernova explosions, we'll delve into the science behind these celestial threats, understanding their origins, their potential impact, and the chilling reality that they pose to our pale blue dot. Fasten your seatbelts and prepare to confront the awe-inspiring and terrifying power of the cosmos. This is a journey to the edge of existence, where beauty and danger collide in a cosmic dance of creation and destruction. Imagine a celestial traveler, a mountain of ice and rock, hurtling towards Earth at unimaginable speed. This, my friends, is the threat posed by comets, remnants from the formation of our solar system. These icy wanderers, often described as dirty snowballs, originate from the distant Oort cloud, a vast reservoir of icy bodies far beyond the orbit of Pluto. This particular comet, let's call it Comet Apophis, has been traveling for billions of years, its trajectory shaped by the gravitational pull of planets and stars. It's a relic from the early solar system, a time capsule containing secrets from the birth of our sun. But its journey, a cosmic ballet choreographed over eons, could end in a catastrophic collision with Earth. Comet Apophis is massive, perhaps several miles wide, and its impact would release an unimaginable amount of energy, equivalent to millions of atomic bombs detonating simultaneously. The consequences would be devastating. Imagine a fiery inferno engulfing the impact site, followed by shockwaves rippling across continents, triggering earthquakes, tsunamis, and volcanic eruptions. The impact would launch billions of tons of dust and debris into the atmosphere, shrouding our planet in a thick veil of darkness. Sunlight would be blocked, temperatures would plummet, and our once vibrant planet would be plunged into a global winter. The impact would be a reset button for life on Earth, a cosmic catastrophe that could extinguish the flame of civilization. But fear not, for the probability of such an event, while not zero, is incredibly small. Astronomers are constantly monitoring the skies, tracking potentially hazardous objects like Comet Apophis. We have the technology to detect these threats and potentially to deflect them, altering their trajectory and averting disaster. The cosmos may hold many dangers, but it also compels us to explore, to understand, and to safeguard our place within its grand tapestry. The story of Comet Apophis is a reminder of our cosmic vulnerability, but also of our potential to confront and overcome even the most extraordinary challenges. While comets lurk in the distant reaches of our solar system, a different threat lurks closer to home: asteroids. These rocky remnants from the early solar system inhabit a region known as the asteroid belt, a cosmic shooting gallery between Mars and Jupiter. Unlike comets, asteroids are predominantly composed of rock and metal, making them denser and potentially more destructive upon impact. Imagine a city-sized chunk of iron and nickel forged in the heart of a long-dead star, hurtling towards Earth at tens of thousands of miles per hour. This particular asteroid, let's call it Eros, is a remnant from the chaotic early days of our solar system, when planetesimals collided and coalesced to form the planets we know today. Eros, however, escaped that fate, destined to wander the solar system, its path a celestial game of billiards governed by the gravitational pull of the sun and its planetary siblings. The impact of an asteroid like Eros would be catastrophic. The energy released would dwarf the power of all the nuclear weapons on Earth combined. The impact site would be instantly vaporized, leaving behind a crater miles wide and hundreds of feet deep. The shock waves from the impact would ripple through the Earth's crust, triggering earthquakes and volcanic eruptions on a global scale. The skies would rain fire as molten rock and debris ejected from the impact site fell back to Earth, igniting wildfires that would consume entire continents. The dust and debris launched into the atmosphere would block out the sun, plunging the planet into a prolonged period of darkness and cold. The collapse of food chains, the disruption of ecosystems, and the potential for widespread extinction would follow. But even in the face of such a threat, we are not powerless. Astronomers are constantly scanning the skies, mapping the orbits of potentially hazardous asteroids. We are developing technologies to deflect these celestial interlopers, altering their trajectories and ensuring the safety of our planet. When a star dies, it doesn't go quietly into the night. Some stars, particularly massive ones, end their lives in a spectacular explosion known as a supernova, an event so luminous that it can outshine an entire galaxy. While beautiful to behold, a supernova within a certain proximity to Earth could spell disaster for our planet. Imagine a star, let's call it Betelgeuse, a red supergiant nearing the end of its life. Betelgeuse is a cosmic giant, hundreds of times larger than our sun, and thousands of times more luminous. It's a star living on borrowed time, its core a nuclear furnace nearing its final moments. When Betelgeuse exhausts its nuclear fuel, it will collapse under its own gravity, triggering a runaway fusion reaction that will rip the star apart in a cataclysmic explosion, a supernova. The explosion will release an unimaginable amount of energy, more energy than our sun will emit over its entire 10 billion year lifespan. If Betelgeuse were to go supernova within a certain distance from Earth, say within a few hundred light years, the consequences would be dire. The initial blast of radiation from the supernova would be lethal, stripping away Earth's protective ozone layer and exposing life on the surface to deadly doses of ultraviolet radiation. The explosion would also unleash a torrent of high-energy particles known as cosmic rays. These particles, traveling at near the speed of light, would bombard our planet, damaging DNA, increasing cancer rates, and potentially even altering the course of evolution. The supernova would also disrupt Earth's magnetic field, leaving us vulnerable to the onslaught of solar wind and cosmic radiation. Our atmosphere could be stripped away, our oceans could boil, and our planet could be transformed into a barren wasteland. Fortunately, Betelgeuse, while nearing the end of its life, is not close enough to pose an immediate threat. However, its eventual supernova serves as a reminder of the immense power of stellar explosions and the importance of understanding the life cycles of stars. Black holes, perhaps the most enigmatic objects in the universe, are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. These cosmic monsters, remnants of collapsed stars, lurk in the hearts of galaxies, their immense gravitational pull shaping the fabric of space-time. Imagine a rogue black hole, a cosmic phantom wandering the vast emptiness between stars. This black hole, let's call it Phantom, is a remnant of a star much more massive than our sun, a star that lived fast and died young, its core collapsing into an infinitely dense point known as a singularity. Phantom is invisible to the naked eye, its presence betrayed only by its gravitational influence on nearby stars and gas clouds. It's a cosmic predator, lurking in the darkness, waiting to devour anything that strays too close. If Phantom were to wander too close to our solar system, its immense gravity would wreak havoc on the delicate balance of our planetary dance. The outer planets would be thrown into chaotic orbits, some flung out of the solar system entirely, others sent on collision courses with their neighbors. As Phantom drew closer to the inner solar system, its gravitational pull would distort the Earth's orbit, stretching it into an elongated ellipse. Our planet would experience extreme temperatures, swinging between fiery infernos and frigid ice ages. The tides would become monstrous, engulfing coastal cities and reshaping continents. Earthquakes and volcanic eruptions would become commonplace as the Earth's crust buckled under the strain of Phantom's gravitational pull. Finally, if Phantom were to stray too close to Earth, our planet would be ripped apart by its immense tidal forces. Our planet, once a cradle of life, would be reduced to a swirling disk of debris, slowly spiraling into the black hole's event horizon, the point of no return. The good news, however, is that encounters with rogue black holes are incredibly rare. The vastness of space makes such cosmic collisions highly improbable. The sun, the lifeblood of our solar system, may seem like a constant, unchanging presence in our sky, but the sun is a dynamic star, its surface a cauldron of boiling plasma and intense magnetic fields. And sometimes, the sun throws a temper tantrum, unleashing bursts of energy known as solar flares. Imagine a massive solar flare, a colossal eruption of energy from the sun's surface. This flare, let's call it solar fury, is a result of the sun's twisted and tangled magnetic fields, which can store vast amounts of energy like a cosmic rubber band stretched to its breaking point. When these magnetic fields snap and reconnect, they release their pent-up energy in a blinding flash of light and radiation, a solar flare. Solar fury erupts from the sun's surface, a fiery tempest of charged particles and magnetic energy billowing outward at incredible speeds. The first sign of trouble would be a brilliant aurora, visible even during the day, as the charged particles from solar fury interacted with Earth's magnetic field. But this ethereal beauty would be a harbinger of chaos. The radiation from solar fury would bombard our planet, disrupting radio communications, knocking out satellites, and potentially even overloading power grids, plunging cities into darkness. The flare would heat up Earth's upper atmosphere, causing it to expand and increasing drag on satellites, potentially sending them plummeting back to Earth. The radiation from solar fury could pose a significant threat to astronauts in space, potentially exposing them to lethal doses. Even on Earth, those at high altitudes or in polar regions, where the Earth's magnetic field offers less protection, could be at risk. While a single solar flare, even one as powerful as solar fury, is unlikely to pose an existential threat to life on Earth, it could trigger a cascade of events with devastating consequences for our technology-dependent civilization. As we've journeyed through the cosmos, exploring the awe-inspiring and potentially devastating power of these cosmic events, we're reminded of our place in the universe. We are but a small planet orbiting an average star in a vast and ancient cosmos. Yet, even in the face of these cosmic threats, we are not powerless. We have the power of knowledge, the ability to understand the universe and the forces that shape it. We have the ingenuity to develop technologies to protect ourselves from these cosmic dangers. And perhaps most importantly, we have the capacity for wonder, for looking up at the night sky with a sense of awe and recognizing both the beauty and the power of the universe we inhabit. So, let us continue to explore, to learn, and to protect our pale blue dot, this precious oasis of life in the vast cosmic desert. For in the grand tapestry of the cosmos, even the smallest of threads can hold unimaginable significance.